All right, moving into lesson 2 for chapter 14. A couple really familiar concepts that you're going to see in this one because it's so closely related to what we did last chapter in chapter 13. Some of it's just a matter of dealing with the wording, like you'll see here in a minute when they refer to the idea of a truth set. This is something we've already done, especially Venn diagrams. So I just want you to see some connection from chapter 13 to chapter 14. So a couple things we talked about in the first lesson, the idea of conjunction. Remember, this is like the word and disjunction, which is like the word or, and dealing with those with certain sets. Last chapter was all about sets of data. That was chapter 13 was sets, and we're now linking sets with logic for chapter 14. So take these two statements. The first one says the P statement, X is a multiple of 3 between 1 and 20. For proposition Q, we have X is a factor of 45. So when it says find the truth sets, all that simply means is what we did last chapter, which is just list the set. So if you look at P where it says multiples of 3 between 1 and 20, well, if we just list the set, multiples of 3 would be those right there for numbers between 1 and 20. And so we're just listing the set. So I wanted you to see that because of just the wording where it says truth set. It just is listing the set or the values or the elements that are in this set that you see right here. Factors of 45 for set Q. So kind of start with the outer ones. We know that 1 times 45, those are factors of 45. If we do 3 times 15, as well as 5 times 9. So those are all of our factors of 45. And so now we can kind of do something that we've dealt with in the past, is the idea of a Venn diagram. And so if I were to create my Venn diagram, so there's our Venn diagram for this. If we were to fill this out, just like we did in the last chapter, remember we always start with the inner piece right there, and we find what those two sets have in common. So if you look, they both have a 3 in there. They both have a 9, and they both have a 15. So those are all that they have in common. And then if we list just the P only values, those things that are in P but not also in Q, we got the 6, 12, and 18. And then over here for Q, the remaining numbers that we have not yet listed, looks like we got a 1, a 5, and a 45. And so that's the way that we filled out our Venn diagram in the past. So now look when you see here where it says find the truth set for P and Q. Just like what we saw last chapter. In the last chapter we saw it written this way, right? But in this chapter you're seeing this symbol, but it means the same thing. We're just finding the things that they have in common. So it's just a little bit of different wording and some different symbols, but it should be a familiar concept that we already know. Same thing with this one in the OR set. Last chapter we saw it written this way, right? This chapter we see it with a V shape, but it means the same thing. And so P or Q again just means you list everything in either set. So I would simply list out all of those numbers. So I'm just going to go left to right on that. So I got my 6, 12, 18, the guys in the middle, and then the 1, 5, and 45. And so that would be the truth set for P or Q. And so really familiar stuff that we're seeing on those. I just wanted you to see the relationship from chapter 14 and chapter 13. So continuing on here for lesson 2. Implications are the phrase if then. You dealt a lot with that when you did geometry. You're going to see some familiar things in this that you did in geometry probably a few years ago. But that's the idea here, is an implication is an if then statement. So the symbol that we'll see for this is like the arrow symbol. So as always, you always need to know kind of 3 things for these. You always need to know the vocab word, which is implication. You need to know the symbol that goes with it, and then you need to know kind of the common phrase, so if then to represent the symbol. So it's really important that you know all those. You're going to be tested on that information. So if you look right here, so P is the cause, which is like the if statement. In geometry, we call it the hypothesis. Q is the result, which is your then statement, which again in geometry we refer to that as the conclusion. So if you look right here, if I have these statements, if it is Saturday, then I will sleep in. So P is the cause or the hypothesis, or here's kind of their fancy word for it, antecedent. It is Saturday. The result, I will sleep in. There's a table on this that we can take a look at for those. I want to show you this one because this is what you're going to be using on your test, is this right here. And this is super nice. In the past, students had to memorize this whole table. It wasn't until 2014 that IB allowed this to be within the formula packet, and kids can now use it on a test instead of having to memorize all these. So again, just to remember the breakdown on this, these two columns right here for P and Q, these are like the given information, and then everything after this line is the response that you would give. The one that we're looking at right now is the implication, which is this one right here. And so the way we want to interpret this chart is, if I have an implication like the one that we just showed in the notes that said, if it is Saturday, so if it is Saturday, then I will sleep in. Well, if the first part of that is true and the second part of that is true, then overall that makes the entire statement true. If the first part is true, so if today really is Saturday, but the result is false, I don't really sleep in, then we would say overall the entire statement is false. If the first part is false, so let's just say today's not Saturday, but the second part is true, I really did sleep in, as long as the conclusion is true, then we would still say the overall statement is still true. For the last one, if they are both false, so if today's not Saturday and I don't sleep in, if both of those statements are false, then overall I still told the truth overall in the overall statement. And so these are the responses that we would come up with to those two statements. So going back to the notes here, I know you guys remember these things from geometry, the converse, the inverse, and the contrapositive. This is always a popular first semester geometry lesson. Deals with those. So the implication, this is the original if-then statement. So if P, then Q. So just to put some phrases into there, if it is July, then it's summer. The converse simply switches the order. So the converse on that would be if it's summer, then it's July. And so that would be the converse. As I mentioned earlier, you always need to know the notation and the words, because in any test question they can ask you for either one or both. Oftentimes they'll ask you for the symbol and the wording, and so it's really important that you know how to come up with both of those. Or they would give you the statement like this and ask you to put in the notation to go with it, which would look like this. And so for the converse, it's just a switch of the arrow on that one. For the inverse, an inverse is when you throw in the word not. So if it is not July, so that's the not symbol that we see right there. So if it's not July, then it's not summer. And so that's what we see right there for the inverse, just throwing in the word not into the original statement that you see here. And again, be familiar with the notation as well as the words that we would throw in. Contrapositive is where you switch the order, so switching the arrow as well as throwing in the word not. So for the last one here, we would say if it is not summer, then it's not July. So a couple of things you just got to remember on that as far as the notation and the wording that we would throw into those. Last example that we got to see down here, an equivalence statement. So this is like our if and only if kind of a statement. Back in geometry, this was referred to as a biconditional statement. But now in our logic chapter, they call it an equivalence statement, an if and only if. So again, be familiar with the symbol, the double-sided arrow, as well as the phrase if and only if. And so right here we said if the first proposition were it is hot, the second proposition is I eat ice cream. So to throw in the phrasing here, we would simply say it is hot. Notice this does not start with the word if. We simply say it is hot if and only if. So if and only if I eat ice cream. And that's how we get our equivalence statement. Notice on this one, this is also on our table of information. So let me show you that one more time so you can see this one. So right here we have the equivalence statement for P if and only if Q. Notice right here that both statements must agree in order for the overall to be true. So if they're both true, then it's true. If they're both false, then it's still true. If they disagree with each other, then that's when the overall statement is false that we see right there.